Okay, so this is section 5.2, solving exponential equations, and this definitely will be a problem that will be on your exam. It's very common to be used on the exams. So for this section, we have a property called the one-to-one property, which states that if you have a to the u is equal to a to the v, which then translates to u is equal to the v. Well, what does that mean? Let's see. Let's use the example problem from the textbook. Okay, so we're going to treat 3 and 27 as our a's here, but we want the a values to be the same. So I'm going to use 3. We want the bottom number, the base number here, to be 3. So the left side's going to stay the same, but the right side's going to be changed. So 3 to what power gives me 27? Well, I know 3 to the third gives me 27. And then the x minus 4 is here still. So if we use our property, a to the u equals a to the v, this means that those two bases go away, and then it becomes u equals to v. So we can do the same thing here on the left. Since I have both of the same a, these are my a's, that means they can both go away. And then what's left is the exponents. And now we just do distributing. Move the 3 over. Two minus 3x is 1x. Divide the 1. And x equals 12. So each of these problems is going to be very much the same. So let's do one that's a little bit more challenging and has more values. So let's do 8 times 4x equals 64. And I wanted to point something out. So in this one, we have multiplication here. So when we cross out our bases, what's going to occur is the multiplication is going to go away and addition will take its place. So we'll see that. We're going to see that in this example. So I see that I could use 4 for this, but I'm actually going to use 2 as my base for this one. So So 2 to the third gives me 8. 2 to the second gives me x. And let's see, 2 to the 6th gives me 64. And then what replaces the multiplication is the addition. So we're going to leave that as multiplication for now, and we'll show in the next step that it turns into addition. So now we use our property. So since all of our a's are the same, we can cross them out. And then whatever's left behind, we add together. So that's a vital thing here. If you forget to add, then the answer will not be what we're looking for. So now I'm just going to move the 3 with the 6 to get x by itself. Six minus 3 is what? It's 3. And then we divide the 2. So x equals 3 over 2. And you might be asking, why do we use 2? Well, in this case, for these problems, we want to have the number to the power. So that's why we don't want to use 4, we want to use 2. This is the better value to use. Now let's do another one. Let's do one with more variables. Let's see if I can figure out another one that we could do. Let's try this one. Let's try 5 to 2x plus 1 equals 125. Okay, so I want to use 5 here. So 5 is going to stay the same. Now, 5 to what power will give me 125? 5 to the second obviously will not be it. 5 to the third. So we use our 1-to-1 property. The 5 goes away. And then we bring our exponents down and simplify. So divided by 2 is going to give us 1. Easy. So let's see if we can do another one similar to the last one where we have to change all of the numbers. Let's do one more. Okay. So 2 is already given to us, so I'm going to use 2. So 2 to the what gives me 16. So we know 2 to the 4th gives me 16. What about 32? 2 to the 5th gives me 16. So then we have the same bases. They go away. Then we get 4 plus 3x. Multiplication gets replaced with addition. I move the 4 over. So x equals 1/3. So this is how you will complete every single problem like this. An additional step that you can make or do for each of these problems is to go back and check your solution. So you'll put what you find for x into the x position in the original equation, and then see if it, so if, like, let's say this number 1, if I were to put the 3 over 2 in the x position next to the 4, and I was to do the math on the left-hand side, it should be equal to 64. So if both sides are 64, we know that our answer is correct. So that is section 5.2 on solving for type 1 exponential equations.